Yes, I'm Azadeh and I'm presenting on behalf of OpenPETase team. The problem that we are trying to tackle and talk about is the plastic waste, and unfortunately the problem is so big and everyone know about it that I don't need to explain more about it. As other team mentioned, the problem is not only in collecting the waste plastic. The problem is how we are going to treat the plastic. Just leaving it in the dump or putting it in some places is not actually a sustainable approach to this problem. So we came with the idea if we can use degrade PET, polyethylene terephthalate, that is the major plastic, into monomers. And then repolymerize it into the PET fibers and use it again and again, and make a closed circle that we can use it again, not just leave it on its own in the nature. And there is enzyme PETase that can do that for us. And this bacteria, it can, as it developed in the lab, it can separate the PETase enzyme. But as we talk about it and approach the problem, it's so everywhere and so spread all around the world that we thought that in order to tackle this problem, the best approach for us is to, for everyone, manage its waste product on its own. You know, in the source that we are producing the waste, if we can handle that waste there, it would be we can save the transfer costs and pollution in the way. We don't have to be worried about if we are going to leave it on the nature and it make any threat the wildlife. So in two phases, we propose that first we can have some centralized centers to tackle the PETs and reduce it into monomers and then use it again. And in the second phase, we were looking to develop a machinery, a device for every person that can use it in the home. For example, how we can find a reliable device like a machine, as we discuss about it, and we talk about it like a dishwashing machine, that we can put the plastic there and use the PETase as a powder or as a solid tablet, and then this machine can set the situation in the optimum situation for the enzyme to active and degrade the PETs into monomers, and then we can use the monomers again. The stakeholders of this fundraise, I think, is so wide. It would be every person or community labs, environmentalists, and general citizen. We talk about three main components in Asia, Europe, and America, and then we can spread this all over the globe to tackle the problem. So, okay, for doing this, we need some research, how to design the device, how to find the process to make the PETase available and affordable for everyone, the hazard and safety requirements, the legal requirements. For example, in some countries, maybe GMOs are, because using the mutant bacteria can increase the yield, and there are some barriers in some countries that by increasing the awareness, we can tackle these problems. And we are thinking about that in a long time, we can encourage people to use this method and handle their own waste in the source. For example, it would be good it would be very interesting for us to use the plastic bottle inside that machine and use the monomers to, I don't know, in 3D printers to make a chair, and use it again and again. And yes, this was our idea of this problem. And thank you.
Thank you, Azad, for representing
Thank you, you
the
too.
team. So OpenPETase is a group from different people from around the globe as friend scientists. So
yes, we have Japan and Hungary. To be honest, and America. To be honest, I don't know about the other countries, but I'm sure we are more. And Africa, yeah, Africa. And I'm from London.
Nice. Thank you for representing the team. I think Jimmy has a question.
Yeah, I don't know if it is a question. I just wanted to say congratulations. I think this is a very good idea because I never heard about anyone that tried to solve the plastic problem, trying to decentralize the thing. You know, like for example, in my city, all landfills of waste are outside the city. We treated the things like that. We just take it away from our view and think it doesn't exist, but it's actually exists, and the city goes grow and grow, and one moment we are going to have to deal with that. So it's a very interesting to try to
yes, because you know, I've been in before this, I've been in a waste product management group, and because it was in that presentation, that conference, that I realized that for example, I think Devin mentioned that I wash my plastic with soap and I make sure that they are clean. But all the people, some people, they might not do that. And even if you wash them and put them in the plastic bag, when they are going to recycle, they look inside, and if they, because plastic are different types, some of them are recyclable, and that manufacturer are doing this, they actually they do that. But if the package that they are putting there are some things that they are not in that good quality, you know, they don't waste their time to separate the good things and they just put the whole bag in the not recyclable.
Yeah,
even if we wash them, even if we put them in the recycling and put so much effort to recycle at the home, in the household, but it's not going to be 100%, you know, if we do it. Because I think at the first place, maybe about, I don't know, I haven't done any research, but I think roughly maybe about 40% of people care about it. And if only 40% of people do this at home, it would be huge. It would be something that changed our environment, and because it's changed the belief of every person, not doing something centralized, pushing them people. And it's a good idea. I have plastic, I don't know what to do it. Okay, I put it there, I have enough. I can do it. I can give it to an NGO that are coming to our house and collect it, or I can, or in future, if we develop with something, I can put it inside my 3D printer and make a new thing, you know.
When you were talking about that hardware that people could have at home, I was thinking, what about if we had a mushroom, like someone talked early, that eat the plastic, and then the post could, like, I don't know, eat the mushroom, but then I thought, no, plastic have some toxic parts that people add to the polymer, so it can have some properties. But I don't know, maybe we could find some cool application that people could do with that type of mushroom that it lasts. I don't know if there is something that people could do with that mushroom. I don't know. But you was thinking about bacteria, right?
Actually, to do it and to be successful, it should be super easy for the end user to do it. It's just like what we put the dish in the washing machine and put the soap. It should be like that, you know. You put the plastic and just put the some enzyme in some ready enzyme inside it, to be super easy for the end customers to do it. Otherwise, they won't do it. And that's the idea, that if it can make it easy for people, I'm sure that it will be successful.
I think Luisa, Giovanna, and Azad should be talking. should talk about, because the ideas are very similar, right? In one sense. But I guess Isaac G has a question.
Yeah, I think my question is more about my I don't have so much knowledge about PETase enzyme, but I remember that when I take a look that actually the reaction of that PETase enzyme makes, it's not so good, right? Takes a lot of time to actually the enzyme to divide in monomers, and I remember that it's not something that it's cost at the time that I take a look. It's not so cost. It would be you have to produce much more than actually recycle. So the cost is not one aspect in this in the enzyme. But maybe I am completely unupdated of everything that works related to the PETase world. So I would like to know more about this.
Yeah, one of our colleagues, he's in Japan, and the lab, they have the mutant bacteria that it can increase the yield. I'm not sure about how much and how much it can improve it, but it's this. Yeah, I don't have the knowledge to answer that questions. But from that side, I've heard that it can improve the efficiency. But the problem is that in GMO is not. Some countries are very strict with GMOs.
Thank you.
You're welcome.
Isaac Clarkey, you're muted.
Yes, good question. Yeah, again, really important problem. Really glad that there's an international team working on doing this in an open source way. You know, I think I would encourage you to think about the policy and the sort of political side of this challenge, as well as the technological side, just because, you know, following on from what Isaac G was saying, you know, this challenge of bioremediation, particularly of like human waste streams, just the way that our economies are set up right now, those waste streams tend to have very low marginal value, and so it's difficult to extract like a private profit from you know, remediating them necessarily, even though there is great public benefit, you know, and global benefit to be had from that remediation. And so, you know, at the policy level, you know, it's the kind of thing where we need to change the structure of how our economy functions, such that there are resources and public capital that go towards both reducing those waste streams and remediating them. And I would encourage you to think about how can you plug into larger movements and you know, systems of organizations that are working on the other aspects of tackling this problem, not just the technological, but the political, you know, like the movements that are working on you know, pressuring politicians to pass legislation reducing plastic waste, you know, the organizations that are working on you know, yeah, those types of things. And you know, the last point I'd make on this is, you know, I've heard a couple of times, you know, you know, an emphasis on sort of like the personal responsibility and like the sort of the sort of end users of these plastic materials needing to clean up and recycle them, and you know, how do we reduce that? How do we get, you know, the huge numbers of people to do those things? I think that is important. It's also important to remember that the sort of framing of, you know, individual personal responsibility for that waste stream in a very similar way to the framing of like a personal carbon footprint, personal responsibility for global warming. That type of framing has actually been developed by like the plastics industry and the fossil fuel industry to redirect attention away from them and get people, blaming themselves and not thinking about how do we organize collectively to build the political power to overcome the industries and basically force them to stop being the primary source of the problem. And so, yeah, I would just encourage you to think whenever you start thinking in those terms of like, all those people not being personally responsible, start thinking more in terms of we need to organize to overcome the power of the industries that are at the root source. Yeah.
Yes, yeah. At the first stage, because the years that we are consider our milestone is to 2050, and at the first age, for example, for 20 years in ahead, our plan was to do this centralized in 3 domains and not by every individual, doing it in centralized industrial plants in different countries, and then little by little encouraging people, to do it on the in their house or wherever they live. At the first phase, yes, it couldn't be happen at the first phase. It should be centralized and in the industrial plants, and gradually we can think about it and we can make it happen.
I think the other thing that I'd like to say is that I think we'll be very interested if you could take your gene, the OpenPETase version, and send to the FreeGenes project, because in this platform, people don't need to synthesize the OpenPETase gene, and they could actually ask for free from the FreeGenes project the OpenPETase enzyme, so they could use in different projects with different strains. And I think would be very important to have more people involved in this enzyme specifically, so they could try different ideas with this enzyme, and could advance more the PETase gene in the way that could be very much more interested to use and have much more discussions about this topic. And having an institute that could provide this for free to anyone around the world would be a very interesting idea for your project that is trying to make the PETase gene open. And
yes.
I think also they have people that could try to tackle the legal side of the gene to see if this could be actually open for anyone. And I think this will be other contribution to a project that will be very interesting to you, actually. And also for I would definitely will talk with other laboratories that I have worked in the past, that the PETase gene is something that we already discussed it, and having a free version of this will be very interested to making this more real to them to actually work with this and try new things. So I really recommend the FreeGenes project for doing this.
Yeah.
Tainá?
Hi. So it's funny because one of our first projects was actually to do a find a biodegradation enzyme here in Amazonas. In the old project, we actually had it frozen a little bit because we didn't have the time or the money to do it. But since we've been talking about doing this research with methods, we've been looking, we're trying to look for a PETase, but actually an Amazon PETase. So it would be amazing so we're talking collaboration wise, it would be amazing to talk with you as that, and also with Giovanna and Luisa. So I think it would be amazing for us to continue this conversation later.
Yeah, I appreciate it. Yeah, it would be beneficial. Yeah.
Yes, for sure.
Thank you for your, thank you.
If you guys want to continue this conversation later, I can give you guys my email on the chat.
Yes, please.
Yeah, I will send again because it got lost in a lot of messages. So I'll send our email again.
A lot of collaborations and projects that would interlink the ideas, right? So this was exactly the point of the hackathon.
Yeah, I love it. Collaboration.
Yes.
Sure.
So here it is.
Do we have any more comments? Okay. So
will the chat be preserved with the recording?
I can save the chat report.
Yeah.
After.
Okay.
Yes. Just Ian K, please don't stop recording so we can have Sibel after we finish. But I think you can